so I can't say that one. Okay.
When you say C7, you have to do this.
I will first look it up before embarrassing myself or getting into trouble. Is it appropriate?
Yeah.
It's just funny. It's just funny. I'll first look it up though. I've been fooled before. All right, guys, back to business. Scale diagrams. So, yes, this section is called scale diagrams, but we deal mostly with scale factors, okay? So a scale diagram, think of a map. A map is a scale diagram, right? It's something in the real world compressed into a small area, okay? So just make sure you follow along now, no talking, okay? So it would be proportionally reduced or enlarged by a constant factor. If you have a cell, if you have the picture of a cell in bio, that's right, a really small thing that has been now enlarged by a scale factor, okay? What's scale? Scale is the scale diagram, right? The ratio of the measurement of a scale diagram to the corresponding measurement on the actual or the original object. Scales can be reduced just like fractions. Different units are okay, but no decimals. That's one thing you need to remember about scales, right? And then scale factor, I'll give it a different highlighter, page 21. Scale factor, K. So K is the letter we use for scale factor. It can be expressed in three formats: fraction, decimal, or percent. Okay? And this is the important one right here. If you have another color, it's very important to remember. If the question asks you to state the scale factor, you want to go make sure there are no units left over. Is everybody back? No units left over. All right. So let's compare scale and scale factor here. Okay. So in general, if we're talking scale, so this is in a sense cutting it in half here. Okay, so you've got scales and scale factors. A scale usually have, these are going to be numbers, okay? Whatever is on the diagram compared to actual. Okay. But, okay, so when we're talking pictures, blueprints, model, anything like that, I like to use the words diagram and actual, okay? If we're making copies, replicas, or making something similar, I like to use the words new and original. Okay? So we're basically doing the same thing, we're just using different terminology. Okay? Scale factor. You take this and you stack it and produce a fraction. So scale factor would be diagram over actual. And it's very important that you don't mix them up. The order matters. Diagram goes on top, actual goes at the bottom. So, okay, I'll just tell you this. The textbook, if you were to have the textbook, it would just stick with those terminologies. Diagram, actual, that's it. I just inserted and I used new and original because sometimes it makes it easier to wrap your head around it. So K, if you turn this scale into a scale factor, you'd have the measurement of the new object up top and the original goes at the bottom. So this would definitely be a study sheet entry in my opinion. Just make sure it's nice and small, like don't use this much space, okay? All right. Scale factor, is it a reduction or is it an enlargement, right? So the scale factor affects the actual or the original, which will result in the diagram or the new version of it, okay? So when you look at a scale or scale factor, it will tell us what happened to the actual or the original. That's what it tells us, like what happened to that original shape, okay? So if K is less than 1, or you can think of it as K being less than 100% if you'd like. Okay, so 1 is the same thing as 100%. You actually have a reduction. Reduction of, can you see that? Yeah, you can't see it. Hold on. Reduction of actual or original. Okay? So we're going to split that up here. Okay? Then you've got k is equal to 100%. What do you think? Did anything change? Nope. No change. It's basically the exact same object. So I'll just leave it at that. If k is greater than 1 or greater than 100%, then the original has been enlarged. So again, I'm going to go back to the cell. If you see the cell on your in your textbook, k would be greater than 100% because the original, like that actual cell has been, right, the picture has been enlarged of it. So here are some examples because sometimes students just need an example. So if k is equal to, let's say, 0.2, or if k is equal to 2/3, it's still less than 1, correct? 2/3 is 0.6 repeated. Okay. Or k is equal to 65%. Anything like that, you know that the original has been reduced. Enlargement, right? K is equal to 1.2, or k is equal to 5/4. 5/4 is 1.2 actually. Okay. Or k is equal to 120%. That means that it has been increased. I normally wait until later, but I'm going to tell you this, okay? 100% is the original copied again. So if k is 65%, how much has it been reduced by? Like the original, how much has it been reduced by to get to 65? 35, right? So if I ask you, how much has it been reduced by, don't say 65%. It has been reduced by 35%, right? How much has this one been enlarged by if you look at the original? 20%. So if you want to write this down, enlarged by 20%, because we go from what happened to the 100. What happened to it? Did it go up? Okay, then it's enlarged by 20%. What happened to the 100 here? Right? It has been reduced, all right, but by how much? 35%. So I know this is tight in my book, my notes here. Reduced by 35%. And this is why I don't use iPads to do my notes, because it's not realistic. Because you'd be like, oh, that was easy. You just moved stuff, right? I want you to know, like, it fit in here, so it should also fit in your notes, okay? Don't have much time, so I'm just going to go to the first example here. 22. Given a scale of 1 centimeter to 50 meters, how do we know this is a scale? I didn't even have to say this. It's because of the colon, right? And you've got different units, so this is a scale. Okay? It says, state the scale factor used. Like, he wants you to turn this into a scale factor. Okay, so I'm going to do that right here. K is equal to 1 centimeter over 50 meters. So you actually just turn that into a fraction. And what's the deal with scale factors? You remember? It cannot have units. Okay, cannot have units. So we need to do some converting. So which one would you convert here? I think it's easier to convert the meters to centimeters. It's easier. It's not like it's the only way. So I'm going to do this. Watch. I'm going to say that 1 meter has 100 centimeters. And guess what's going to happen here? Cancel, 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 cancel. All units just cancel out. 1 times 1 is just 1. 50 times 100 is 50, followed by 2 zeros, right? These 2 zeros. So voila, you've got your, this is technically, right, the answer as a fraction. What about decimal? I go comma, I want to state it as a decimal. My calculator moved here. Use your calculators on this one because something annoying is about to happen when it comes to this part. Every once in a while you will encounter this issue. So you go 1 divided by 5,000, right? And you get that. I'm going to do an aside here for you. If you turn that into a fraction, right, the calculator shows 2e negative 4. What do you think that means? Scientific notation, it's a poor job, right? It's basically saying 2 times 10 to the negative 4. That's what it's saying. Okay? But I want you to state it as a decimal. So this is my trick. This is just my trick. What you do is you take that number, leave it there, you just go plus 1. Like add something to that number. And then it's going to force it to actually write it as a decimal. So what are we going to write down as a decimal? We're going to ignore that 1, but we know that it's 0002, right? 4 decimal places. That's why it's to the negative 4, right? It's 4 decimal places back. So the trick is to add 1, okay? Add 1. Okay, and then it will look like this. And obviously we just write this part down in our final answer. Some of you look at the scientific notation, you just know what needs to happen. But if you don't, that's what you do. So to get this into a percentage, we just multiply this by 100. Okay, so I'm going to show you that if you multiply that by 100, the decimals will shift over 2 spots. So this is 0.02%. So it's very, very small. Okay. B. By how much has the original been reduced? You got to go 100 minus 0.000. Oh, sorry guys. Just leave it there. Your only homework is what? Finish the AC. Okay? We're going to continue with this tomorrow.